Hi all. In the last video, we spoke about deletion operation in a heap, right? In this video, we'll talk about building heap, how you create a heap. So, usually you will have a binary tree or you will get an array. You will get a binary tree in the form of an array, right? How you build heap out of it. You will see the procedure, how you can build a heap using an array or a binary tree. Okay, now this is the array I have got as shown here. Now this array I represent in the form of binary tree like this. Like what the easiest way to represent is I can just take these elements as is and arrange level by level. So first level, if you take, as I said already, maximum number of nodes, like maximum number of nodes that can present at each level is 2 power d. Now let's say I'm at first level, 0th level, okay, first 0th level, 2 power 0 is 1. To second level, 2 power 1 is 2. Third level, 2 power 2 is 4. So likewise, 90 I take at first one, and the second level I should have 2. So 23 and 5 I'll put it here, and the third level I should have 4 nodes. I'll take the next 4 nodes here, 109, 12, 22, 67, and the last one I'll put it here. This is one way of representation, and the other way of representation is 0th index is always the root node of a tree, right? And its left and right children lies at 2i plus 1 and 2i plus 2 indexes, as I was showing here. Okay, now if you see this diagram, it is at 0. 2i plus 1 is 1, 2i plus 2 is 2. So whatever is present at the first index, I put it as left child. Whatever is present at the second index, I put it as right child. And for 23 index is 1. So what should be the left and right childs? 2 into 1 plus 1 is 3 and 2 into 1 plus 2 is 4. So 3 and 4 I put it here. This is another form of representation using the formulas, but simply you can follow this 2 per d, like at each level the maximum number of nodes is 2 per day. You can follow that formula. Okay, now you have build a like you just represented it in the form of a binary tree. I want to build a heap. This is not a heap, right? This is not either a maximum heap or minimum heap, because 90 is greater than 23 and 5. 23 it is lesser than 109. 5 is lesser than. It's not a heap because there are lot many elements that are in zigzag fashion. So to build the heap, you remember insertion operation in the heap, right? What you have done in an insertion operation. If you remember, what we have done is the process is you insert the element at the end of the heap, and then you compare the element with its parent and push the element to the root node till you get a heap condition. That is inserting a single element. So for creation, what you have to do is, now first you assume you have a single element in a heap, that is 90. Okay, I'll take 90. So a single element always follows the heap property. It can be considered as a maximum heap or it can be considered a minimum heap. So this followed the heap condition. Now I add one more element to the heap. Okay, 23, 90 and 23. So ideally you will add at the end, right? At the end you will add element and then you keep swapping it. Here I added 23 and I compare with the parent. Okay, when I compare with the parent, what happens is, when I compare with the parent, it is already following the maximum heap condition. Okay, it is already following the maximum heap condition. No need to do any swapping. Okay, so that's it. So this condition is satisfied when we inserted the second element. Okay, now I take the third element. Third element is 5. So what I have done is 90, 23 is already there. I inserted 5. Like usually in an insertion operation, what you do is you go to the last level and you insert it at the last. Okay, I inserted 5. Now I'll check this 5 with the parent. I have to follow only 2 steps. Insert the element at the end of the heap, compare the element with its parent, and then keep swapping the values till you reach the root node of the tree. Here I had inserted 5 and then I tried, like I checked with its parent. So parent is already greater than 5. So no need to swap it. So it is already following the heap condition. Now I insert next element 109. 90, 23, 5. So at this level, how many nodes should be there? It is the second level. 2 power 1 is 2 nodes. So this level is completely filled. You cannot add any more nodes to this level. Okay. Now then I have to add 109 here. Now what I'll do is I'll follow the second step. Compare the element with its parent and then swap the values. So compare the element with its parent. When I compare the element with its parent, it is 109 is greater than 23. So I have to swap it. What I did is I swapped these two. When I swapped, after swapping, this is the operation. Like this is the heap. 23 and 109 are swapped and then you have this. Now I'll compare 109, okay, 109 with 90. 109 is greater than 90, okay. So what I'll do is I have to swap 109 to 90. So my heap after adding 109 is 109 is at the root, 90 is here, 5 is here, 23. This is my heap now. Okay, this is step 4 because we have added 4 elements. Now in the step 5, you'll add 12, okay. Now I have added 12 here, okay. This is the heap I got from the step 4 and this is 12. Now 12, it is already lesser than 90. So no need to do any more adjustments here, okay. Now I'll add 22 element here. When I added 22 here, you insert the element at the heap, compare the element with its parent. When I compare the element with its parent, what I have done is I should swap it because 22 is greater than and we are building a max heap, right? So I swap the elements 22 and 5. So when I swap the element, my heap looks like this. 22 goes above and 5 comes down. Now I add the other element 67. So when I added 67, I'll add, this is the heap I got from the previous step, right? So 67. Now here what I should do is 67. I compare with the parent. 67 is greater than its parent. So I should swap it. I move 67 here and 22 here. 67 goes here and 22 comes here. This is my heap. Now I'll compare 67 with 109. 109 is already greater than, no need to make any adjustments. Now this is my heap. And one more element is 34. Okay. Now I'll have 34 here. I'll add 20. This is the heap I obtained from the previous step. Here I added 34. When I added 34, what I have to do is I have to compare it with its parent. When I compared with its parent, 34 is greater than 23. So what I'll do is I'll do swapping, okay, 23. Now 34, I'll compare it with 90. 90 is already greater than 34. No need to do any swappings here. So are there any elements? No, 34 is the last element. So this is my maximum heap. If you see here, this is a complete binary tree and 109 is greater than 90 and 67. 90 is greater than 34 and 12. 67 is greater than 5 and 22 and 34 is greater than 23. So what I have done is I took and basically I got an array and I built heap out of it. Okay. So what I did is I take each element one element one by one element and I build heap using insertion operation, what we discussed in the previous video. Okay. Now I have built a heap. Let's calculate the time complexity to build a heap. Okay, so the time complexity, if you saw the insertion of an element in the heap, we have inserted a single element and the time complexity is log n, where n represents number of nodes. Here what we have done, we are inserting n number of nodes. So here first we inserted 90 and then you inserted 23, then you inserted 5. You are doing insertion operations n number of times. And for each operation, as we discussed earlier, time complexity is log n. So to build a heap, for building a heap, time complexity of creating a heap is n log n. Okay. Time complexity of creating a heap is n log n. So this is the time complexity of creating an heap. So that's it about building a heap. In the next video, we will talk about heap sort. Thank you.